Researchers have been amazed at the mathematical knowledge that is encoded into the Great Pyramid, the measurements that are used in it.
What if everything we thought we knew about the pyramids was wrong? For centuries, historians have said they were built by ancient Egyptians using simple tools and human effort. But now, Grok AI is making a bold claim, one that could change the story completely. According to its findings, the real builders might not be who we think they are. And even more surprising, it says there is proof to support it. Join us in this video as we dive into what Grok AI revealed, what the evidence shows, and why this discovery is raising so many questions. The line between what we know and what we don't. Grok AI does not claim to know who built the pyramids. That answer simply is not in the data, and the system clearly recognizes that limit. What it produces is not some bold new conclusion, but something far more interesting, a precise boundary, a line drawn between what the current explanation can fully support and what it cannot. On one side of that line, we have what is already accepted. There is strong evidence tied to domestic Egypt, records of organized labor, remains of worker settlements, tools made of copper found in proper archaeological context, and clear signs of a structured workforce operating across the Giza Plateau. These details are real, grounded, and they hold up under scrutiny. No serious analysis removes them. But on the other side of that line, there are observations just as real and far harder to explain. The pyramids show a level of precision that pushes beyond what even modern construction consistently achieves. Their alignment with astronomical points is incredibly exact, beyond what we typically credit ancient builders with being able to measure. There are mathematical patterns embedded in the structure that seem to appear long before those ideas were formally understood. The cuts in granite don't always match what copper tools should be capable of producing. There is also a noticeable lack of earlier versions or developmental stages leading up to something as advanced as the Great Pyramid. And then there's the Sphinx, whose weathering patterns suggest a timeline that doesn't fully agree with the accepted construction date. These are not guesses. They are measurable details, and they do not fit neatly with the evidence on the other side. Once that boundary is clear, a few possibilities begin to take shape, and none of them are simple. It's possible that domestic Egyptians had access to construction methods or tools far more advanced than what has been discovered so far. Maybe this knowledge was limited, used only for major royal projects, and lost over time. Another idea is that they inherited knowledge from an earlier civilization, one that existed during a time when the Sahara was greener and supported larger populations than we usually imagine. There's also the possibility that the Sphinx's geological evidence is pointing us towards something much older, that the Giza Plateau may have been a site of major construction long before domestic Egypt, built by a civilization we have yet to fully identify. Each of these ideas fits parts of the evidence. None of them explain everything, and none can be completely ruled out. What Grok ultimately shows is not an answer, but a gap. The question of who built the pyramids is still open, and maybe it always has been. The explanation that has dominated for decades isn't necessarily wrong, but it may not be complete. It has held together through consistency within specific fields, and in some cases, because no system has ever forced all the evidence to be examined together at once. Now, that has changed, and the result isn't a wild theory, it's something more unsettling. The realization that the current explanation may not be enough. The pyramids are still there. Their measurements haven't changed. The marks carved into their stones remain exactly as they were. But the question behind them, what truly made all of this possible, can't be pushed aside so easily anymore, because a simple answer isn't always the right one. And that may be the most uncomfortable truth of all. So what patterns appear when we examine everything more closely? Keep watching to find out. The patterns Hidden in plain sight. In 2024, Elon Musk's Grok AI was given something unusual: wide, unrestricted access to nearly everything we know about the Giza pyramids. This wasn't just a handful of reports. It included over a century of archaeological surveys, engineering studies, astronomical alignment records, mathematical research, geological data, and detailed analyses of tool marks. The instruction was simple but strict. Study the data as it is, without bias, without trying to defend old ideas, and without forcing a familiar conclusion. What came out of that process wasn't just a new take on one strange detail. It was something broader, a pattern that kept showing up across completely different types of data, all pointing in the same direction. One of the strongest findings involved the pyramid's proportions. When the base perimeter is compared to the height, the ratio closely matches 2 pi, the constant linked to circles with an accuracy of about 0.05%. Then there's another set of relationships connecting the height, base, and slope angle that align with the golden ratio, phi, a number that wasn't formally described until over 2,000 years later in ancient Greek mathematics. Looking at just one of these might not seem like much. It could be chance. But Grok didn't find just one. It identified at least 7 separate relationships within the same structure, all pointing to these same constants. When those are taken together, the idea of coincidence starts to fall apart. The odds of all of them appearing randomly in a structure supposedly built through trial and error are extremely low. Then, the analysis went a step further. When the pyramid's height is multiplied by 43,200, the result closely matches the Earth's polar radius. When the base perimeter is multiplied by that same number, it closely matches the Earth's equatorial circumference. That number, 43,200, is not random. It matches the number of seconds in 12 hours, a basic unit of time, which raises an interesting possibility. This scaling may have been chosen on purpose. Engineers and surveyors who looked at this method agreed on one thing: the chance of these relationships all lining up by accident in one structure is almost zero. And that leads to a difficult question. Because if these measurements were intentional, then the builders weren't just stacking stone. They were working with an understanding of the Earth itself, its size, its shape, and how to represent it in a scaled form. According to accepted history, that level of knowledge shouldn't have existed at the time. So the focus shifts. It's no longer just about how the pyramid was built. It becomes about who had the knowledge to design something like this in the first place. But what do the physical marks carved in stone reveal? Stay tuned to find out. Marks in stone that don't match the story. Mathematical patterns can always be debated. With enough flexibility, some will argue they're just coincidence. But physical evidence carved into solid stone is much harder to explain away. That's where Grok AI turned next, focusing on the granite used inside the Great Pyramid of Giza. The system compared known toolmark databases with the granite structures deep within the pyramid, especially the king's chamber, the sarcophagus, a stone coffin, typically adorned with elaborate carvings or inscriptions, used in ancient times to hold a body or a smaller coffin, and the chambers above it. These blocks weren't local. They were transported from Aswan, over 800 kilometers away. That alone is impressive. But what matters more is how they were shaped. The issue starts with hardness. Granite contains quartz, which ranks a 7 on the Mohs hardness scale. Copper, the strongest metal available in Bronze Age Egypt, sits much lower, around 2.5 to 3. In simple terms, a softer material shouldn't be able to cut cleanly through something much harder. Instead, it should leave uneven marks, with cuts that drift when they hit tougher spots inside the stone. That's exactly what modern tests show. When researchers try cutting granite using copper tools and sand, the results are messy, irregular depths, rough surfaces, and lines that don't stay straight. But that's not what we see inside the pyramid. The cuts in the granite there are different. They are straight, they are smooth, and they stay consistent even when passing through sections of the stone with different hardness levels. That kind of precision doesn't match what copper tools are expected to produce. One of the clearest examples comes from an object known as the Petrie core, first studied by Flinders Petrie in the late 1800s. It's a cylindrical piece of granite with a spiral groove along its surface, a clear sign of drilling. Petrie measured how fast the drill must have moved into the stone with each rotation. The results suggested a level of pressure and speed far beyond what ancient hand tools could achieve. More than a century later, engineer Christopher Dunn looked at the same object again. His conclusion was striking. The marks on the core looked similar to those made by either a diamond-tipped drill or a system using ultrasonic vibration, methods that transfer energy directly into the material. Neither of these technologies appears anywhere in the known archaeological record of ancient Egypt. Grok didn't stop there. It compared these granite marks with modern cutting methods, diamond saws, high-speed drills, water jets, even ultrasonic machines. The closest matches didn't line up with ancient techniques at all. That doesn't mean modern tools were used. The system doesn't make that claim. What it does show is something more unsettling, that certain parts of the pyramid were shaped using a method we cannot currently place within the known capabilities of that time. The tools we believe were used don't match the marks left behind, and whatever did create them hasn't been found anywhere else in the archaeological record of the civilization we credit with building the pyramid. So what happens when we step back and examine the whole structure? Let's find out. A structure that refuses to fit the story. The Great Pyramid of Giza is made up of around 2.3 million stone blocks, each weighing between 2 and 15 tons. These stones are fitted together so tightly that you can't even slide a piece of paper between them. It once stood 481 feet tall, and for nearly 4,000 years, nothing built by human hands surpassed it. Not until 1311 AD, when a cathedral spire in England finally rose higher. Now think about that for a moment. A structure said to be built using copper tools and wooden sleds held the world height record for 4 millennia. According to archaeologists, it was ordered by Khufu around 2560 BCE. Workers cut the stones, dragged them across the ground, and lifted them into place using ramps, ropes, and manpower. There's evidence to support parts of this. Ancient records describing labor crews, tool marks on the stones, and even remains of worker settlements found nearby. On the surface, it sounds reasonable, but that explanation starts to fall apart when you look closely at what was actually built. The level of precision in the pyramid is extreme. The alignment, the flatness, the exact positioning of massive blocks. This isn't just good craftsmanship, it's accuracy that pushes beyond what modern builders consistently achieve today, even with lasers and computer-guided machines. Then there's the mathematics embedded in its structure. These aren't simple ratios. They reflect knowledge that wouldn't officially appear in human history until thousands of years later. And perhaps most striking, despite over a century of research, no one has ever successfully demonstrated how ancient workers could move and position stones this massive with this level of precision. Not once. Attempts have been made, theories proposed, but none have fully recreated the results we see standing on the plateau. For a long time, anyone who raised these issues was pushed to the side, labeled as fringe or unrealistic. But ignoring a question doesn't make it disappear. And in this case, the questions have never really been answered. What makes this even more complicated is a piece of evidence that's been sitting in plain sight since 1858, the Inventory Stela. This isn't a modern theory. It's an inscription written by ancient Egyptians themselves, and it describes the Great Sphinx of Giza as already old, already standing before Khufu began building the pyramid. That directly clashes with the standard timeline, which credits Khufu with ordering the Sphinx's construction. Scholars have known about this inscription for more than 150 years, but instead of resolving the contradiction, it's often set aside without a clear explanation. Then there's another layer, one that raises questions about how the modern narrative itself was shaped. Mark Lehner, whose mapping work became a key part of how the pyramids are dated today, played a major role in building the current academic framework. But early in his career, his research was funded by the Edgar Cayce Foundation, a group known for supporting the idea that a lost, advanced civilization may have built the pyramids. That detail is rarely discussed. The same figure who later became a central voice defending the traditional explanation began his work backed by people who believed something very different. And that shift has never been fully explained. Taken together, all of this creates a picture that feels less settled than it appears. The pyramid still stands, unchanged, but the story we tell about it doesn't seem to fit as neatly as it once did. But how fast would all this really need to happen? Keep watching to find out. Every 2 minutes for 20 years. One block every 2 minutes. That's what the math demands. To build the Great Pyramid of Giza within the commonly accepted 20-year timeline, workers would have needed to quarry multi-ton stones, move them into place, and set them with near-perfect accuracy every 2 minutes, non-stop, for 2 straight decades. No breaks, no delays, no room for error. Just a constant rhythm, day after day. Let that sink in, because once you do, the standard explanation starts to strain. The stones themselves only deepen the problem. The outer casing stones, which once covered the pyramid, were fitted so tightly that the gaps between them averaged less than half a millimeter. Today, even skilled builders using advanced tools, diamond-tipped saws, laser levels, precision grinders, say that level of accuracy is extremely difficult to achieve. Researchers have tried to recreate this using tools from ancient Egypt. The results have been consistent. The gaps they produce are measured in centimeters, not millimeters. Not close, not even in the same range. When Grok AI analyzed what it would take to achieve that kind of fit, it came down to 2 possibilities. Either the builders had measuring tools capable of detecting differences smaller than a millimeter across huge stone surfaces, or they relied on trial and error, adjusting each block over and over until it fit perfectly. But if it's the second option, the timeline collapses. Hundreds of adjustments per stone would stretch construction far beyond 20 years. It wouldn't just be difficult, it would be mathematically impossible. Then there's the King's Chamber, and this is where things shift even further. The ceiling is made from massive granite beams, each weighing up to 80 tons, brought all the way from Aswan. These stones had to be transported along the Nile, hauled across open desert, lifted about 60 meters into the air, and placed with incredible precision. And once in place, they've stayed there, unchanged, for over 4,500 years, surviving earthquakes in a region known for seismic activity. No one has ever successfully shown how an 80-ton block can be moved across sand like that without modern machinery. Attempts have been made. None have worked. The ramp theories don't hold up much better. A straight ramp long enough to reach the top would stretch for over a mile and require more material than the pyramid itself. A spiral ramp wrapped around the outside should have left marks on the stone, but those marks aren't there. Internal ramp ideas struggle to explain how the highest stones were placed or how the ramps were later removed without leaving any trace behind. When Grok ran the numbers on these models, every version came with the same issue. Either the workforce becomes unrealistically large, or the timeline stretches far beyond 20 years. And then there's one final detail inside the king's chamber that changes the picture entirely. No body was ever found there. The stone coffer inside the chamber was completely empty. No mummy, no artifacts, nothing. Acoustic studies in the 1990s revealed something unexpected. The chamber produces resonance patterns that match the rhythm of a human heartbeat. Engineers studying it concluded that the space appears to have been designed with acoustics in mind. It also holds a steady temperature of about 68 degrees Fahrenheit year-round, which happens to match the average surface temperature of the Earth. A tomb doesn't need any of that. So whatever the king's chamber was built for, it likely wasn't a burial. The deeper this goes, the harder it becomes to connect the structure to the tools we believe were used to build it. And when Grok examined the actual physical marks left behind, the cuts, the drill holes, the grooves, the mystery sharpened even more, because those marks don't match what we expect from ancient tools. They match methods we didn't develop until the 20th century. So, what do you think about Grok's new findings? Let us know in the comments section below. In the end, this wasn't just about who built the pyramids. It was about the limits of what we think we know, the gaps we choose to ignore, and the evidence that refuses to stay silent. If you enjoyed this, like, subscribe, and stay tuned for more stories that challenge everything we thought we understood.